Some discussions, not very hard, I have to confess. The 5GIA votes for us, for Valencia, for the I-Team, for the Universitat Politécnica de Valencia to co-locate the 7th Global 5G event with the EuCNC. And even more recently, very recently I would say, the Celtic event joined as well. So maybe I should start over my initial words saying, welcome to the Valencia 5G Week. This conference is really special, a unique occasion, and we assume the responsibility with confidence and with a team of enthusiastic young researchers of the I-Team Research Institute that these days you will see around identified as the staff. After a lot of preparation work, we had the support of the European Commission, the City of Valencia, the regional government, Generalitat Valenciana, the IEEE Communication Society and the EURASIP. And also, of course, we had the participation and the support of the patrons, mainly Orange and ZTE, but also Huawei, Ericsson, Nokia, Kenmei, and Vodafone Business. Let me express on behalf of the organizing committee and also my personal gratitude to all of them. In this year's edition of EuCNC, we have gathered a very high-quality set of tutorials, workshops, keynotes, panels, and a wide variety of topics related to the current trends on mobile communications, from 5G and onwards, as well as on the expected revolution that these technologies are about to boost in several industry sectors, enabling the smart connectivity society of the future. I would also like to thank the steering committee and the TPC members, the tutorial trainers, the workshop, panel, and special session organizers for their commitment to this event, for the cooperation to make this entire program a reality. Thank you very much. Also inside this amazing conference center, the Valencia Conference Center, you can also enjoy the highest number of exhibitions we have so far in the EuCNC series. We had a total of 70 exhibitors with almost 30 live demonstrations on every 5G vertical applications, but also on the future wireless and optical communications beyond 5G. We are also welcoming to this edition of EuCNC many participants from other regions of the world, from Asia, USA, Australia, Africa, Americas, the Middle East. So everybody is represented here in this community of the telecommunications and the mobile communications engineers. This number is increasing every year. Maybe this time we are reaching or approaching the 20% of the total participants. You will discover Valencia during your stay. A sunny city full of amazing sights, from the historical city center to the very modern buildings of the City of the Arts and Science, the beach, the sailing port, the natural parks nearby, and our old riverbed, nowadays a breathing green central park of 7 kilometers all along the city. But Valencia is really more than that. Valencia is full of entrepreneurs, talent, knowledge, which emanates from our universities and research centers, and it's crystallizing every day in new technology companies. All those added to some of the leading industries on logistics, agriculture, health, automotive, harbor, all that make Valencia well on its way to become a technological pole in the Mediterranean. To conclude, 5G is today's evolution of the mobile technologies, aimed to be tomorrow's revolution of the industry. So be welcome to discover the way beyond 5G at EuCNC 2019 in Valencia, where we could start writing the future of mobile communications. Thank you very much. So now we have, I want to call to the stage Mr. Manuel Sánchez Malagón, Director of Network Planning of Orange Spain. Say a few welcome words to the audience. Thank you.
Thank you, Narcís. Buenos días a todos. Good morning, everybody. Our CEO, Laurent Payassot, already launched many messages on the opening session of the 5G Global event, so I will perhaps now speak a little bit, only a few words, about personal feelings around this conference this week. First of all, I would like to apologize on behalf of Monica Sala, who wants to be here, who wanted to be here, but unfortunately she couldn't attend. 15 months ago, I had a meeting with Narcís, who told me that both 5G Global event and the European conference were going to take place at the same time, June 2019 in Valencia, this marvelous city. By that time, we were designing our trials, 5G trials, and Valencia was one of our choices. So we decided to strongly engage with the Polytechnic University of Valencia and also with our partner CTE and benefit from the 5G deployment with SA architecture. Today, I can say that we took the right decision with the right partners. And now Valencia is becoming leader in technological innovation, attracting talent and enterprises. I just only hope that we will keep on working together for the benefit of the citizens and the whole society. Thank you very much.
Thank you very much, Manuel. Also, as I mentioned, we had strong support from the European Commission, so I would like the Director of Future Networks, Directorate of the DG Connect at the European Commission to address the audience with a few words from the European Commission perspective. Mr. Pierce O'Donoghue, thank you.
Perdón. Buenos días, estimado señor el presidente, estimada señora la vicealcaldesa. Gracias de recibirnos y de la parte de la Comisión Europea. Quiero darles las gracias y felicitarles por el trabajo y sobre todo a Narcís y la Universidad Politécnica para tener esta conferencia. This annual conference and the global event that has just come before are two very important milestones each year in the work which the European Union is doing with the member states, with regional authorities, and of course industrial players and research institutes to develop 5G and to ensure that Europe has a key position in what will be a crucial new means for economic and social development across the European Union, to keep Europe strategically competitive, but also, more importantly, to give all of the advantages that the new technologies can bring to European citizens. And we are very impressed by the dynamism and the commitment of the university in not only organizing this event, these events, congratulations, by the way, but also, in fact, the role that you play, iTeam plays, and other teams have played in a number of our research projects, some of which you can see showcased outside, and which show the strength and which show that the ambition, for example, for Valencia to become a technological pole is something which is not only on the way to being realized, but it is something which is very important for European partners who are involved in 5G. So I would like to encourage you all to continue the work. I would like to thank the city and regional, the community authorities for their support. And I would like also to thank all of those of you who are here, who are participating actively in our 5G activities. I will explain a bit later what it is that we want you to do in the future. But for the moment, I wish you all a very good conference and thank you all for being here.
Thank you very much, Mr. Donahue. And I would like to call to the stage illustrious Deputy Mayor of Valencia City, Ms. Sandra Gomez.
Presidente de la Generalitat, ladies and gentlemen, good morning. Bienvenidos a Valencia, benvinguts a Valencia, welcome to Valencia. It's a pleasure for me and for the city of Valencia to receive the great experts in new revolution of communication, the 5G technology. Many people are talking about 5G technology that will increase the speed of connection of mobile device. But the most important is the latency. And we were still beginning to explore the opportunities in this new era of communications. In this way, the city of Valencia is transformed into an opportunity for 5G. Valencia is a beautiful city where culture, tradition, and innovation coexist, but also is an opportunity for the economy and business. Valencia has proposed to be a vanguard of the new economy, and part of this target is based in the development of 5G. Valencia is ready to be a 5G reference center where companies can explore new solutions, where startups can develop new products, and where citizens can take advantage from the impact of 5G in their daily life. That defines progress, not only technical progress, but how it makes people advance. Valencia has set out to be a tech city, a city of talent, a city where you can develop technology and innovation, and a city of opportunities, a city that advances without leaving anyone alone. Valencia is an opportunity, and we want to share it with all of you. Better connected people, new opportunities, and social progress. That is technology. Welcome to Valencia Tech City. Thank you very much.
And finally, I would like to call to the stage el molt honorable Presidente de la Generalitat Valenciana, Mr. Ximo Puig. Thank you.
Good morning, buenos días, bon dia. President del Comité Organizador, estimado Narcís, Director General de la Unión Europea, Directora Técnica de Orange, Delegado, autoridades, vicealcaldesa, señoras y señores. Me hubiera gustado poderles saludar el lunes y compartir con ustedes la inauguración de este evento, pero circunstancias relacionadas con la toma de posesión del nuevo Gobierno me lo impidieron. En cualquier caso, quiero, como ha hecho ya la vicealcaldesa, darles las gracias por haber elegido Valencia y esta comunidad valenciana para la realización de este evento extraordinario. Muchas gracias a los organizadores, muy especialmente a Narcís, por haber conseguido que este gran evento se haga en la Comunidad Valenciana, y ya saben que ahora y siempre esta será una tierra abierta, hospitalaria, una ciudad en la que se combina, por una parte, lo que es la tradición, las raíces, la cultura centenaria, con la ambición de una mirada de futuro absolutamente conectada a la cultura tecnológica y la ciencia.
Ladies and gentlemen, I would have liked to have been here on Monday to greet you and inaugurate this formidable event. However, on Monday, the formation of a new government of the Valencian community took place, and as you will understand, my official duties prevented me from attending. In any case, I thank you immensely, firstly, for choosing Valencia and our community as the location of this global 5G event.
Sabemos que el 5G abre un horizonte extraordinario. Es un tiempo de científicos, tecnólogos, pero también de soñadores, porque las primeras posibilidades que se abren reflejan simplemente, y lo vemos en este evento, reflejan un horizonte espectacular. Sabemos que el 5G será capaz de aportarnos una gran potencia a las empresas, a las universidades, pero también a cada una de las personas. Necesitamos introducirnos en esta revolución digital porque va a ser fundamental para la productividad y, por tanto, la mejora de nuestra competitividad y también, en definitiva, la posibilidad de tener en Europa una potencia tecnológica de primera magnitud.
The moment is for scientists, technologists and also for dreamers, because the first possibilities that open up in the wake of 5G, as reflected in the program of this event, we see it's going to be simply spectacular. However, we are only barely scratching the surface of what 5G will be able to offer us. We are yet to witness its full and widespread use in the wider university and business spheres.
Porque no hablamos solo del efecto sobre las empresas, sino también, como les decía, las consecuencias directas sobre los ciudadanos. Hablamos de sustituir tareas repetitivas por funciones cognitivas de mayor valor añadido que necesariamente supondrán cambios en los modelos educativos y en los mercados laborales. Hablamos de proteger una privacidad de las personas compatible con el uso de las grandes masas de datos que nos proporcionan las tecnologías.
We are not just contemplating the outcomes on businesses, it will also have direct consequences on citizens. We're looking at substituting repetitive tasks with cognitive-driven functions with greater added value. All this necessarily implies changes in educational models and in job markets. We'll be having to deal with protecting the privacy of people while being compatible with the use of the great masses of data that will be generated by 5G technologies.
Hablamos de la presencia de los gobiernos y las administraciones públicas en el empleo de nuevas oportunidades que nos aporta el 5G, en sanidad, en prevención de riesgos, en eficiencia de los servicios públicos, en movilidad, en seguridad, en control del cambio climático. Hablamos, pues, de un paso más hacia un cambio de era, desde el Homo habilis al Homo digitalis.
We are dealing with the presence of governments and tiers of public administrations when considering the new opportunities driven by 5G. To mention a few: health, risk prevention, the efficiency of public services, transport and safety, and also, of course, in the control of climate change. We are speaking, therefore, of one more step towards a change of era, from Homo habilis to Homo digitalis.
Ante la dimensión de semejante cambio, es fundamental el liderazgo de la Unión Europea y por eso agradecemos mucho la presencia del director general y agradecemos que Europa tenga una visión clara a favor de una estrategia sobre la inteligencia artificial. Pero tenemos dos tareas urgentes también desde lo local y global. Dos tareas desde la Comunidad Valenciana en las que nos sentimos concernidos. La primera es que hay que estar de forma activa en el desarrollo, la difusión y el empleo de las oportunidades que proporcionan las tecnologías basadas en el 5G. Y también, por otra parte, aspirar a que la invención y la innovación nazcan en nuestro territorio, en nuestras universidades, en nuestros centros tecnológicos.
The magnitude of this change employs, I believe, greater leadership from the EU. We must take stock also of two urgent tasks in regard to both. The Valencian Committee is deeply committed to these two. The first is that we'll be very active in the development, extension and use of opportunities offered by 5G-based technologies. We also want to ensure that the invention and innovation will take place on our soil. To that end, we have considerable expertise offered by the 5 Valencian public universities, among which notable mention must be made of the one hosting us today.
Les invito a conocer nuestros proyectos, el Hub de Valencia y también el Distrito Digital. Son experiencias importantes en este aterrizaje de la sociedad valenciana en la nueva economía. El Gobierno valenciano ha incluido una novedad importante en este nuevo mandato, que es precisamente la creación de una consellería, de un departamento de innovación, universidades, ciencia y sociedad digital. Es, sin duda, la apuesta más importante para ese concepto de aterrizaje de la economía valenciana en la nueva economía.
I invite you all to get to know this initiative we've taken here of the Digital District. To this end, the Valencian government has done something groundbreaking this week, the creation of a new ministry or department of innovation, university, science and digital society. The concept of digital society is geared at the second task, the task that I referred to before as being urgent.
Para acabar, simplemente una reflexión sobre que las tecnologías pueden triunfar como grandes hitos de la genialidad humana, pero también pueden fracasar como reserva de los valores sociales que sostienen la libertad, la solidaridad y la convivencia. Por tanto, es fundamental, es imprescindible también el debate sobre la ética y lo que significa la capacidad de adaptación en la libertad en todo este movimiento.
We know that these new technologies will pose new heights in human ingenuity, but we must take care that such advances will not undermine the social values on which liberty, solidarity and community cohesion are based. This is why debate involving technical, ethical and normative aspects is absolutely essential. We are indeed at the gates of a new territory.
Los gobiernos necesitamos de sus reflexiones para conocer qué nuevos marcos regulatorios son aconsejables y qué modalidades de innovación social resultan recomendables para que el cambio se contemple también desde esa mirada humana en favor del crecimiento del ser humano. En cualquier caso, muchísimas gracias por estar entre nosotros. Tengan la seguridad de que nos sentimos honrados de acogerles ahora y en el futuro y espero que sea un gran éxito porque este éxito será un éxito en favor de la humanidad. Declare inaugurat la 28ª edició de la Conferència Europea de Comunicacions. Muchas gracias.
Governments are interested in your reflections to work out the most advisable regulatory frameworks. It involves identifying the most advisable forms of social innovation so that we can face the change with hope and favouring all human beings. Once again, thanks for participating, for being amongst us, we Valencians, in this quest. We would be most honoured to see you again at future hostings of 5G global events. I declare the sessions open. Thank you.
Thank you.
Okay, so thank you very much, the authorities, for these warm welcome words. So now we continue with a more technical program, or the European Conference has recently opened by the President, with a presentation from Perth O'Donoghue, again on stage, the Director of Future Networks at the DG Connect, the European Commission. Thank you very much, Perth.
Okay, ladies and gentlemen, so back again, as they say, sin transición, the more technical part of what I wanted to say to you, but which is very important for the debates that we're going to have and what you see outside for the next couple of days. I very briefly want to put in context the work that we are doing on 5G development, particularly the research and innovation parts, but also how that links importantly to central parts of the European Commission, the European Union's economic development strategy. So very quickly what I'm going to do that in context. Explain a bit what we have achieved together under the 5G public-private partnership, and then talk about the opportunities that are coming up in the next year for further work in regards to developing the 5G technology. More importantly then, we need to look at the future, how we work at a level of the European Union, the new financing programs that will be put in place over the next year for the period 2021-2027, and particularly how we design specific programs to work on ICTs in general and on communications technology in particular. And then how do we bring that together into a more comprehensive or coherent policy framework to develop the next generation internet and to ensure that Europe benefits from smart networks and services. So this I'm going to do quite quickly. Don't worry, I'm not going to expect you to read everything that's on my slides. But I wanted to stress what we all assume that we know, but it's worth reflecting just very briefly on what is actually the value of what we are doing. Why are we spending so much time and effort with regard to 5G and those communications technologies? It represents something close to 300 billion euros that could develop for telecommunications, which could be about 30% of all the benefits derived from ICT. That's about 3% of European GDP. And it could actually grow as other sectors decline and as the ICT sector actually replaces others in terms of employment, wealth generation and prosperity for the communities across Europe. That's about 1.1 million jobs that we predict can be created in the mobile ecosystem, 1.4 million indirect jobs. And of course, as we have been pushing already for 5G for some time, it is a technology to drive economic development. We're no longer talking about the ICT sector or the telecom sector. We're now talking about technologies for all sectors of the European economy, all elements of social life as well, whether it is health, public services like public transport, as well, of course, as development in sectors as diverse as energy, agriculture, agri-food, logistics, etc., etc. So you will see some great examples outside of the projects where already we're working on what we call the verticals to show how 5G can directly benefit and create a communications, technology and data environment for the development of all of these sectors. It therefore will become central to our competitiveness and the growth of the European Union in the future. Those are the reasons, that's the motivation, that's the justification for spending time and money with regard to the development of 5G. At the moment, we are at the delivery of the third phase of our trials and infrastructure innovation projects. This is a very busy slide. I don't expect you to see it more. You can have these slides available to you afterwards. But what I wanted to show you is that this is something that is across the breadth of the European Union, where we have either poles, we have technological development centres, and we have cross-border collaboration with regard to the creation of a platform of 5G technologies, which is the networks and infrastructure, the equipment, upon which are then constructed trials in different sectors and for different applications, for vertical industry use cases that will run on top of this end-to-end platform, which will be seamless, but also will be completely transparent. That is to say, the user doesn't need to know about the technology, but it will adapt itself in real time to the user's needs and to the sector's needs. So we have already a number of projects with a total of about 90 million euros that are being launched now as a result of phase 3 in building on top of the platforms that we have already been constructing under phase 1 and 2 of the research work under the PPP. This is technology which, just as you will see outside, is now moving from the existing standards, from release 15 of the 3GPP standard, moving towards standalone 5G in its real pure sense, where we can now show, whether it is politicians or regulators from cities, from countries, and industries, what this actually means in real time. Those of you who were there last evening will have seen that we did a demonstration to show, not just to you, but also to a series of police chiefs and directors of emergency services from this region as to exactly how 5G can apply in real-life emergency situations for the work that they do. One of the particular focuses of the work that we have done has been on connected and automated mobility. And there are ambitions here in Valencia to have a test center for autonomous driving. But that is a flagship initiative in the sense that it is quintessentially work that builds on top of work that's been done in regions and member states. For us, it has a specific cross-border element. That isn't just to justify its existence. It's because when we design these technologies, it has to be pan-European, it has to be seamless. The handover which we used to accept and still accept for mobile roaming will not be acceptable when it comes to continuous autonomous processes, and particularly sensitive ones such as autonomous driving. Whether it is platooning or fully autonomous mobility, clearly we cannot have signals being dropped just because a vehicle is crossing a border. So this is why it actually creates technical challenges that we need to adopt and that we need to address at European level. So we have a number of corridors that have already been identified where there are trials going on. This builds on top of national trials as well. And we have a series of target use cases. It's not the only one, but we have close to 1 billion euros being spent with regard to this family of technologies. And then if I just broaden that out to the wider spectrum of trials and platforms, we have 180 trials across Europe, 147 of them in the European Union, working also with partners outside of Europe in order to ensure that this is something that we are working together on. Those 28 countries are committed to advancing Europe with regards to 5G, and they deal with a whole lot of different applications across media, entertainment, of course mobility, as I've said, but also industry and logistics. There are quite a few projects in Western Europe, but we are trying to ensure that other countries, particularly in Central Europe, are also involved. Then, if I look at what's coming next, the existing funding programme is coming to an end, but it has life yet in it. We will have one final call for proposals under the 2020 work programme, which will, subject to approval, be launched in July 2019, and will also act as projects which are started next year and which will then transition over into our next framework programme. It is essential that we keep up the effort. This is proof that we are continuing at full speed in the development, but also looking ahead now to the creation of an ecosystem of smart networks and services built on the 5G platform, fully integrating cloud, IoT, and the other technologies that you hear so much about. Because, of course, we have to now bring 5G to the center of everything. Just as a lot of the focus will now move to artificial intelligence and to data, it is essential that you, as the technologists who best understand this ecosystem, are in a position to explain and integrate the role of the connectivity platform, the seamless and effective low-latency broadband technology that 5G represents, so that AI can be a success, so that we can actually take advantage of high-performance computing, so that actually we can apply the new breakthrough technologies in sciences across medicine, health, transport, and public services. So this is a great challenge, but also a great opportunity. And we want this to be embodied in the call for proposals for next year. Because then very quickly we will move on to the next funding programme. And this is what I just wanted to draw your attention to. In recognition of the importance of digital technologies and, of course, of data technologies, as well as continued work under our Research and Innovation Framework Programme, which will be called Horizon Europe, where there will be an important element of work done on 5G and beyond 5G. We also have a specific programme for the first time called Digital Europe, which will focus on the capacities, the rollout and the actual implementation of these technologies at scale across Europe. So it is a further bridge towards implementing the work that is now being done at research and innovation level. And for those companies, industries and startups who perhaps have generated from initial research projects, this is also a great incentive to stick with what you are doing, because now there will be financial support to gain critical mass in actually implementing at scale the technologies that have been developed. So that meshes with then further work that we will do under the Connecting Europe facility, another name for you. Those of you who have worked previously in the energy sector or in the transport sector will know about CEF, as we call it. But now, under the new program, there will also be a dedicated section of that program for broadband and 5G rollout, specifically. So that is a huge advantage, but it's also recognition that we need to put European money behind the development of these technologies as they are becoming available through the research and innovation work that you are doing with us. So those will also be operating in tandem with other with other programs such as that on media, such as that on data, to create an entire digital ecosystem being funded and supported under the new program. And specifically, if I look at Horizon Europe, which is, shall we say, where many of you will have been most comfortable in the past, in the Horizon 2020 and our framework research programs, I can assure you that even though we move towards the funding of innovation, large-scale capacity rollout, we still, of course, maintain a focus on what used to be ICTs in the research program. We have a specific cluster on digital and industry where there will be a focus on those key technologies that I've named. This is part of a package which will be worth nearly 100 billion. There are 3 pillars, but as you see in the very center of Pillar 2 is that digital and industry cluster. And that is something where we will be giving you more information over the coming months as the Commission releases our strategic programming documents for comment, for input, and for negotiation with the Member States in order to ensure that we have consensus on exactly how we design and implement our research. And again, only to prove the point that it is at the center of everything, and that's why we've highlighted it in red. You see in the very middle in that cluster, under digital and industry, the key elements of the work that we're going to do. Next generation internet will incorporate our work on connectivity and infrastructures. And we hope to create a partnership similar but evolved from the PPP that exists now, with a greater involvement of member states as 5G and the connectivity and broadband become strategically critical, just as we see already with regions and governments of the member states investing in this work. We need that investment to be coordinated and to be focused at European level. What we cannot afford is a significant overlap and waste of resources, and this is why we feel that in designing a partnership for the future, we need to have member states more closely involved. So that is, in one slide which nobody can read, a map of what our research programming will look like in the future. But as I said, the key point is that digital and the next generation internet are at the center of everything. So what does that look like in design? Because we want there to be the infrastructure and connectivity layer, we also want to focus on the services and applications. So all of the work in testing in terms of vertical applications will continue and be enriched by work that we want to do with regard to a whole series of technologies that will only operate properly on this ultra-fast, ultra-reliable 5G platform that we are designing with you. And then, of course, there will be a number of technologies and demand pull issues, such as artificial intelligence, which will determine and shape to a certain extent the work that we're doing. And across all of this, we will have to, from the start, think about security by design. Given what we know, what I've said at the start about the vital economic importance of 5G, because it will be strategically vital for all sectors of the economy and society, for that same reason, it will have to be ultra-reliable, trustworthy and safe. So cybersecurity will be an essential feature. We have to build in trust and security so that it can be rolled out safely and so that we can allow these systems to have effective control of many levers of the economy. Excuse me. Finally, then, very briefly, this partnership on smart networks and services. There was an interesting discussion yesterday as to whether we were going to have 6G or beyond 5G. What I'd like us to focus on at the moment is work on smart networks and services. We are still in discussions with member states in order to ensure the best use of money. and also as to the exact structure of that partnership, which is also a discussion that we're having with you. I'll be discussing with some of the representatives of the Industry Association here today, and with representatives of the IoT Association up in Denmark on Thursday, to make sure that we can have a coherent and well-supported approach to this partnership, and also so that we can show to others who are, shall we say, bidding for that money for other purposes, that this is something that needs to be privileged, needs to be funded in accordance with the funds available. So there will be these activities with regard to higher capacity, looking at the spectrum challenges, moving into terahertz and flexible use. Also, of course, as I've said, building in this security by design, privacy and security by design. And as the president of the region just mentioned, meeting some of the other societal challenges, including and specifically that of climate change, ensuring that the applications that we design are actually contributing to low carbon use, zero net carbon use in all sectors of the economy. That's one major and ambitious objective. But also getting our own house in order, making sure that communications technologies are themselves responsible towards the environment, moving towards zero carbon, offsetting carbon, and using the best technology available to lower the carbon footprint of all elements of the ecosystem, including and particularly data centers, data storage and processing. Just as 5G and IoT generate masses of data, we have to ensure that the systems are more efficient with regard to the use of energy. So, finally, on the smart networks and services, the point of this slide is actually to show you the complexity of the ecosystem, but also that it seeks, in creating this partnership, to integrate all of the key elements. Rather than dealing with the technology on its own, we need to look at the services, at the users and the use cases, to integrate seamlessly and in a transparent way the various vectors of communication, be it high speed, be it broadband, be it low data rate, censoring, etc., into something that is coherent, efficient, and above all, effective in providing the needs of the various use cases. We are in the middle of negotiations towards these partnerships. Your support is essential. In the coming months, with the new Parliament in place, there will be the final negotiations on the shape of our research programs, but also the money that is devoted to each of the activities. And that is why, in terms of the strategic research agenda that we've already worked out, we need to be sure that Smart Networks and Services has pride of place in that work. Your support is vital. We've just started. Outside in the conference, you will see some of the impressive results that you and others have been responsible for in terms of delivering on projects. But now we need to extend and integrate other technologies to ensure that we are preparing and presenting a coherent picture that will put Europe front and center in terms of the lead on connectivity and on 5G and beyond. We are committed to taking a strategic approach. We hope that you will take this journey with us, because we demand and depend on your participation to make this a success. Thank you very much.
Good morning. I'm not Narcisse, as you may have noticed already, but Narcisse had to leave the room, so I'm replacing him. So I'm Luis Correa. I'm the head of the steering committee. Thank you, Piers, for bringing us the views of the European Commission and also of all the challenges that we have ahead. And without further delay, we don't have time for questions. My apologies for that. We are running a little bit late. But we do have time for our keynote speakers, and to be very unpolite to shorten their talks, especially to John Cioffi, not, of course, nothing intended against Johannes, but John just came from the other side of the Atlantic. So, and John is a good example. You have his CV on the program, so I think I'll save some minutes not reading his CV. But John is a good example of, I think, what we want to achieve as well, which is mixing in Europe, mixing academia and industry, and having really the merger of the two to push things forward. So, John, the floor is yours, please. Thank you.
Well, thank you very much for that kind introduction, and I'm happy to be here today. I hadn't been to this EuCNC before. You have a wonderful conference here. I saw the exhibits outside, so thank you very much for the opportunity. I noticed one of the themes here is smart connectivity, and in particular, I'm going to be speaking here. You can see my title here. It says Wi-5G, and I spelled it out. The first two letters in English of 5 are FI, right? And it kind of speaks to the thought that in wireless technologies, and as we go to increasing connectivity, we're going to see 5G and Wi-Fi roaming between one another, but in many cases sharing of the same spectrum band. And so looking at that, what can we do? What is one of the smart technologies that we can use to try to make the most efficient use of the spectrum that's available, make our communication systems work better? And there's going to be a little theme in here. I call it ergodic spectrum management. I'll explain that as we proceed. But keep this in mind, this Wi-5G, if you will, the convergence of the two wireless technologies. I'll talk a little bit about quality of experience and then move on to some resource management concepts, and finally the ergodic spectrum management concept. First off, I think sometimes we, especially in the technical community, tend to use the two terms quality of experience and quality of service interchangeably. They're really not the same concept, although they are related. Quality of experience has to do with whether the user of the internet, as you can see with my little diagrams here, is happy or sad. Happy, obviously it's working and you're getting the content that you would like to have, your application is working. Sad being the situation which I'm sure most of the people in the room have experienced probably within the last week, where you've had your service drop, whether it's a call or you're trying to look at a video, it starts and stops, it sticks, and so forth. So your experience would not be good in that situation. And this tends to result, how does the customer express that they're having difficulty with their connection? Well, they may call and complain to their service provider. They may go to a chat room and complain, ask for help. There are things called mean opinion scores on the service that can be used to characterize that contentment with the service. And even simple things like buttons where you say like or maybe not like or dislike the service. And also one of the metrics you would see here is a customer dropping the service either temporarily or switching providers. That means they're not happy with the service. So that's quality of experience. Quality of service is things that we engineers like to use, like packet error rates or bit error rates, outages where the service is out and it forces a retrain of the system, data rates, particularly variation in data rate in use, signal to noise ratios, received signal, strength indication, and so forth, and efficiency, bits per hertz or bits per area are used. So these are the technological parameters we use to characterize networks, and not necessarily the same thing. So we're going to talk about that difference a little bit here today, and how we can use that and exploit that to better manage our systems. As an example of a quality of experience metrics, there's this thing that's increasingly you hear about called buffer rage. And it's basically, it has a formal definition now, you can find this on the internet, a state of uncontrollable fury or violent anger induced by the delayed or interrupted enjoyment of streaming. So customers get angry, believe it or not, you see almost half the customers experiencing this, even late 2018, on a regular basis, daily basis. And this is despite all the innovations, 4G, 5G, Wi-Fi, fiber increasingly penetrating the networks, convergence with software-defined networks and virtualized network functions. So what this can mean is often the quality of service metrics, remember we just talked about that, meet the targets, but the quality of experience for the customer of the internet service is still not good. So here's an example. This is a picture or diagram that you see often in 5G documents. I think many people use it. And it's got this nice massive MIMO antenna array in the middle of the of the diagram, and because of the array beamforming that's possible with multiple antennas, each user getting their own uninterrupted service without interference. So it looks very clean and organized. And of course, the cell phones out there could be other devices, television sets, automobiles, industrial equipment, whatever it happens to be that's getting service. So we tend to have this view of that's where everything's going with our latest technologies. But in reality, this is what we get, which is a mess. We don't have that nice central, all the beams in the right places. Things are overlapping. They're interfering with one another. And this is a situation, particularly with Wi-Fi systems today. And 80% of the world's internet traffic is carried on Wi-Fi, not LTE or licensed spectrum these days. So this is the real situation. And even if we start to, and especially if we start to use things like LTE signals in the unlicensed bands, or LAA as that's sometimes called, this will just simply increase this particular mess of transmissions, different directions, even with multiple antennas. So for me, this is reminiscent of something that we saw 20 years ago. I've modernized it a little bit here with my first diagram, but there used to be something called asynchronous transfer mode switching. In the latest kind of viewpoint where we have a software-defined network, we could see that being centrally controlled and maybe having a data plane with switches in it, ATM and the switches today. That might be software-defined network, and LTE 4G, 5G being the data plane, the connectivity, if you will. And what you tend to see here in this viewpoint, both 20 years ago and today, under the analogy here, is this centralized control concept. Large telcos, incumbent service providers or large service providers who have control of the spectrum and the system. They own the switches or the data plane. They own the spectrum, and LTE, it would be the analogy to that. And they manage the switches and the spectrum to avoid conflict, and a single entity or maybe a few entities will control. So that's maybe 2000 ATM on wires, 2020 LTE 5G on wireless. What actually happened, if you've been around long enough, and I have been, you remember this huge conflict between the ATM switching technologies and TCP/IP, which of course is the protocol used across the internet. It's a distributed type of protocol. There was no central control. Essentially, the control was put in the endpoints of the network, and applications developed over the top of the internet. And some of the largest companies in the world, of course, today exploited that infrastructure. Amazon, Apple, Google, Facebook, Baidu, pick your favorite large company. So it wasn't this centralized type of system. The actual technology that was used underlying most of this was Ethernet technology. It's not as good as ATM from an engineering standpoint, but nonetheless, because it put the control in the hands of the users as opposed to a centralized group, it prevailed. And that is the technology that's used everywhere in the world today. So this distributed TCP/IP took over. Control is local or more distributed. It does use the same infrastructure, but the real control is in the endpoints with the users. And here's just a picture of the internet today, this mess out there. And so what I'm saying is this analogy in 2020 now is kind of the ATM viewpoint of this is the LTE side, okay? The centrally controlled, everything single entity versus Wi-Fi today, which is distributed everywhere, but carries most of the data. It's probably not nearly as good a technology as the LTE in terms of the engineering level design of it, but nonetheless, it's very prevalent. So following this analogy a little bit, if you're to look at the TCP/IP solutions that emerged as the winner there, the router is used as distributed technology. And you could think of the routes themselves. The analogy today would be the actual channels for transmission that are used in wireless. The root cost is basically, which is one of the metrics that's used to decide the path through the internet, is the quality of experience. The IP address is the radio node color, or its identity. The spanning tree protocol that's used is not too much different than some of the protocols you see for mesh technologies of Wi-Fi networks building upon themselves. The interior protocol, which is kind of the ATM protocol, that's a single entity that did not prevail in internet routing, is kind of the equivalent of the old radio resource management. And what I'm saying is the exterior protocol that did prevail earlier, and the analogy says that's Wi-Fi today, is this ergodic spectrum management that I'm going to tell you about. So dynamic routing protocols learn the statistical consistencies of the path through the internet. I'm going to introduce a concept we call a learned resource manager, and I'll tell you a little bit more about that, but it can learn the statistical consistencies of radio networks. If you haven't heard the term ergodic before, many engineers have. What it means is basically time averages are equal to statistical averages at a single point in time. And they call that an ergodic network. So what we're going to be looking for is the statistical consistencies and trying to exploit those into management in a little more distributed way of the network. And it's, of course, any kind of consistency is over a certain time frame, but a reasonable time frame. So let me pursue that a little bit and go back and look at resource management basics. Let's start maybe with a single radio access node. It has a few devices in its little region that it's contacting. And let's say there's some cloud management. I'm going to call that an LRM, or Learned Resource Manager. And the dotted lines here are going to represent kind of management flows, things that can be decided or controlled. There's going to be a management interface to the cloud. And you can think of this as Wi-Fi and or LTE here. And then there's a second network, maybe overlapping with the first network. If this was your Wi-Fi system, this would be all the SSIDs that you're seeing when you're choosing a Wi-Fi network, and they use the same spectrum. And maybe there's a third network here, and we have this concept in the cloud of being able to pass information back and forth between kind of the control systems. So similar to the routers we're talking about in the internet. And this is where the artificial intelligence is going to go at that level, just as it did in the internet. And this is where the quality of experience metrics are going to be fed in as inputs to say, okay, are we improving the system quality as we do this? Okay, so let me move on to just a very important concept here is going to be dimensions. I like to think they underlie all of communications. Here I just have a plot of a spectrum over 20 megahertz wide bandwidth, which is one that's typically used in Wi-Fi and in LTE. And if you're to look at second generation systems, they're only about 300 kilohertz wide. Here I happen to put a 200 nanosecond second path into the transmission. So there are two paths, and when they're 180 degrees out of phase, you get these notches. And the old 2G systems, if they were in the wrong place, they're using the wrong dimensions, so to speak, they could be notched, or you lose the signal. What 3G did was it went to a wider bandwidth. The hope with some coding that you could recover whatever's lost through the wider bandwidth. And then 4G went to even wider bandwidths, 20 megahertz. And in LTE, we tend to divide this over time and frequency into nice little blocks, and they're allocated to different users because the central system can organize that efficiently. And then we've added the dimension of space. Here I'm showing 8 transmit antennas and 8 receive antennas. And so what that does is it allows us to add more dimensions spatially to the system. In addition to time and frequency, we now have space. And as long as the antennas are a half a wavelength or more separated, and the wavelengths are getting smaller and smaller, so that's possible to do, this can become a new element that can be exploited. And really, as we go 4G to 5G, we're starting to do that also, is exploit space and try to call it up. Now, if you look at Wi-Fi, it's one of the older types of protocols. It's a collision-based protocol. And so users will try to randomly transmit, and if they detect that someone else is using the channel, they'll wait a random period of time before they transmit again. That works okay when the system's not very loaded. as you get increasingly loaded, around 30% or more, the throughput of all the users will rapidly go to zero, and this is something you experience, for instance, in a conference like this. Sometimes the Wi-Fi system, you can't even download your emails. It's because too many people are using it. So both will wait a random period and try again. LTE, of course, avoids that particular problem by assigning everyone their own dimensions, if you will. And 802.11ax, the latest standard, sometimes called Wi-Fi 6 these days, actually tries to avoid that a little bit in some of its use of spectrum. So LTE, you would call this an interior routing protocol, centrally coordinated. It would avoid the common spectrum or dimensional use. And the sharing would only be accomplished through purchasing the services of someone who owns the spectrum, sometimes called a mobile virtual network operator. And there may be some borrowing from adjacent cells. This is called COMP in the 3GPP standards, the LTE standards. And so movement into unlicensed spectra these days is controversial. We see both in Europe and the United States the concerns about the 3.5 gigahertz band, the 6 gigahertz band, and the different types of uses, be it the licensed LTE type of signals using unlicensed spectrum or just Wi-Fi. Is that fair? So, okay, this fairness concept and use of spectrum comes down to something I like to call loading. What is loading? Well, we have a basic communications channel here. It's got some signal-to-noise ratio characteristics that may be different on different dimensions. Think of that as different frequencies. Some noise is added. I like to characterize that by something we call G, the channel gain. And it can be measured by the transmission system. And it's kind of an inverse noise figure. Basically, the more useful parameter is 1 over the gain, as we'll see shortly. And the signal-to-noise ratio is basically the energy times this gain that you get on the channel. It varies for wireless channel. The ergodic spectrum management I'm going to talk about will work with the distribution of this G rather than the instantaneous value. And if we have a set of dimensions that we're using, whether that's in spectrum or over space, we can actually represent that as a single wider channel by taking the geometric average of this particular quantity here, which is basically taking the product over all the dimensions that are used and then taking the nth root of that product. So here's some examples of that. If you have a channel that might have signal-to-noise ratio that varies with the dimensional index, you can think of that as frequency. You might have different signal-to-noise ratio, have different information carried. But you can represent that by a geometric equivalent single channel, as I'm showing here. You might have another type of channel that has equal energy on all of the transmitted dimensions, and that obviously can be represented by a single signal-to-noise ratio. You may have another channel that has a different signal-to-noise ratio, also represented by a geometric average. And we have a last one. There may be some of the channels are on and off, and we can represent that also by a geometric average. And then we can look at the set of different channels and say each one of those is represented by one of these parameters, G, and we can run an optimization routine over that and decide which of those channels should I actually use for transmission. It may come out that 3 of them are good, and 1 of them we don't want to use. We'd rather put the energy on the other channels. I like to call this nested loading of the system. And there's a classic solution to this problem. Now I'm thinking across different channels and different frequency bands and so forth. But the solution to this problem was given by Shannon in his famous 1948 papers called water filling. And the basic idea is you take this 1 over G quantity that I said was important, you multiply it by a constant that just basically characterizes the type of coding being used, and you take the energy you have available, which is represented by blue here, you pretend it's water, and you pour it in from above. It will sit at a constant level across the different systems, this is the optimum spectrum use that you can make of all of these systems. So I'm not talking about doing this within an LTE band or single channel or a Wi-Fi band. I'm talking about doing it across the channels, okay? So it's at a higher level. But this is the best energy distribution that you can use if those channels and their geometric averages are known. Now, it's kind of interesting to look at Wi-Fi, which has 21 20 megahertz channels in the 5 gigahertz band, and there are another 3 that are independent of one another in the 2.4 gigahertz band. And you can have up to 4 spatial streams of that. So roughly there's 64 to 128 possible channels that you can use. Now there's thousands of tones, if you're familiar with the multi-carrier transmission technologies underneath. I'm not talking about those. I'm talking about the channels themselves. And if you go to AX, which has even more antennas, you can have up to thousands of these channels. LTE also uses a fairly narrow, wide, what are called resource blocks. They're 180 kilohertz wide. And so what you can do here with whether it's Wi-Fi or 5G, you can actually look across the available resource blocks or channels and do water filling, okay, and decide the best spectrum use. And going back to Shannon, as long as this is stationary at some moment in time, or you know something about it that's consistent, you can exploit that. That's the best thing to do. Okay. So now what happens when you have multiple users? Well, here's a classic problem that's sometimes called the cocktail party problem that I'll get to in a second. But basically, you can have different Wi-Fi systems overlapping in terms of spectrum. And this causes the contention problem we spoke of earlier. We can try to resolve this by using different channels, but who controls which channel is used? And the classic problem, the cocktail party problem, is here you have many people in a room, maybe it's after the conference here, and there are many conversations going on, and someone can't hear because other people are talking in another conversation. So the young lady here says, "Talk louder, please." And what happens is that interferes with the other group, and they start talking louder, and eventually nobody in the room can communicate. Okay, this is the problem with the contention protocols that we see today. And in fact, this is what happens in Wi-Fi systems today, is they all tend to operate in this form, and it causes a contention problem. So now I get to my theme here, or my major point, ergodic spectrum management to try to deal with this. I'll organize this into a few stages. Some of the people at my company have been proposing this in various standards groups. We have an editor that works for the Wi-Fi Alliance, which is an area that we're trying to promote some of this in the future. Go through a few stages of improved, basically, distributed management techniques all the way through to a final stage, which would require some synchronization of all of the different radio nodes that are active or participating. As a basic technique, I'm one of the 4 co-authors on this from 20 years ago that's used in fixed line systems that with some modifications can be used again in wireless. It's called iterative water filling, and it's basically taking that water filling diagram that I showed you for a single user earlier and using it for each of many users who are all trying to occupy the same frequency band. And if you do that, they all tend to fight with each other a little bit, but the system converges, and it converges to a pretty good solution. Here's an example. The water is the blue, and the inverse signal-to-noise ratio is the red. So the first user water fills, but that creates some interference to a second user, which is the light blue on the right-hand side. And so then that second user water fills on top of that, but then that changes the interference to the first user. And you proceed through this, and this will almost always converge to a stable equilibrium point. That equilibrium point may not be optimum for multi-user systems, but it's often a very good solution. It's much better than what you would normally get. Here's a simple channel with a couple of users, 2 frequency bands. Let's call them channels A and B. Different gains, 0.9 and 0.1 on the crosstalk paths, or 0.9 and 0.9, and then the actual transmission paths shown there. If you run this technique on this simple example, you will get an energy use pattern for the 2 users where they share one of the channels, and one of the users occupies completely the other channel. Now, if you were to look at CSMA, Carrier Sense Multiple Access, the basic Wi-Fi technology, and normalize this to 1, or you would get 4.7 bits on that, but you can get with this water filling about 5.3 bits at 13% gain in this simple case. If we were to actually increase the probability of collision to 50%, CSMA fails, you get 0 bits, you still get 5.3 on the water filling technology for this particular example. So as the usage goes up, it's advantageous to try to do this optimum spectrum allocation as opposed to this contention protocol. So how would we actually implement this with these types of distributed systems? Well, we'd have a radio node. It could be an access point. It could be a 5G, 4G radio node itself. And it supplies some data back to the cloud manager, the learned resource manager. And that data can be the energy it used, the gains that it mentioned, maybe the channel, and other parameters, probability of error, bit error, packet error, other types of quality of service parameters. And then what happens, what comes back, is not a specific command, but a policy. Basically a functional description of how much energy and what types of codes to use in different situations. And so if you do that across multiple users, you can implement the type of thing I showed you on the previous slide. So it's providing a policy description from the cloud as opposed to radio resource management or the kinds of things you see in SON, self-optimizing networks, and wireless where that's centrally controlled. This has worked more off a random distribution. Now you can take it up a level and get a little more complex. It turns out the optimum solution for this problem I showed you earlier can be computed as a simple problem. In general, it's a very difficult optimization problem to solve. It's an NP hard. There are solutions known for it. But it turns out to be actually an FDM solution, which maybe for you would have done anyway, is to give one of the users one of the channels and the other user the other channel, but do that on the basis of the probabilities so that they don't collide. Now in this case, the ergodic approach is up to 7 bits over the 4.7, improving even when the probability is only 10% of a collision. And of course at 50%, we'd have an infinite gain for this. Now you can simplify these optimal techniques to basically do what I call orthogonal dimension division. It's like frequency division, but it means using space as well. And you learn the statistical characteristics in the cloud. You take advantage of that, and you can provide the policy guidance to each of the radio units. Now, some of the simplified methods for approximating the optimums are basically something called multi-level water filling. It's been around for a while. You try different levels on water filling for different systems, different water levels, and you can get very close to optimum solutions. These are basically convex approximations to the more complicated NP-hard problem to solve. So that's the stage 2 or orthogonal system, and you can actually come up with simple algorithms that basically, based on the data in the queue to be transmitted for the different users, you can look across that queue, pick the maximum, and then begin to assign channels, and then deleting the channels from the set, and you will get pretty close to optimal solutions in this case based on the statistics, the probability distributions which the cloud controller, the LRM, is actually computing. Stage 3 requires some level of synchronization between the different radio nodes, but there are ways to accomplish that. Even in some of the Wi-Fi standards today, they have beacons that can be used for that. And you can actually tell who's in your access point, who's in another one through these colors that are transmitted. And there are ways conceptually here to use massive antenna arrays to coordinate them at each of the downlink transmitters to different users. And as well in the upstream direction, you have a single one from all of the users to the uplink, I should say, direction. And there's a way to actually further eliminate the interference. This works. It's pretty close to optimum when the number of antennas is much greater than the total number of users. Here's just a simple example. I had 5 antennas and 2 users. And you can show that this method here, with just synchronization, no other coordination, you're within 1 dB of the true optimum solution for these types of systems. So if you can synchronize, you can do even better. I won't go into the details there. So this is using the energy for the different users. What about the codes? This is where we get back to the quality of experience. There's something called the modulation encoding system that's often set according to quality of service parameters today. They instantaneously measure the gain, not the statistical gain. And a high gain usually means larger attempted data rate. And a good radio modem design in isolation will try to pick the biggest constellation and the highest code rate that will be sustained across the system. This is a quality of service type of design, not quality of experience. And this is a mathematical equation, but basically says maximize the data rate subject to keeping the bit error probability below a certain threshold and the outage probability, loss of service, below another threshold. And you can, this is some details on the formula, but that's the basic idea here. If you go to quality of experience, instead we're going to be actually looking at the probability of good experience. Now, how do we actually get that? Well, there's a log likelihood ratio, LLR, quality of experience. It's basically the ratio, and you take the log base 10 of that, of the probability the user's happy over the probability they're not happy. And if you get +2, it means 99% of the time they're happy. That's going to be very good quality of experience. +5 means 5 nines reliability, which telcos have used in the past. So the trick here is, how do you know this probability of quality of experience? Well, this comes from the complaint calls, the likes or dislikes or unlikes, dispatches, mean opinion scores, customer service drops, and so forth. And that kind of data is available. There's a time lag sometimes when you can get it, but if you use that to train and compute this probability quality of experience, then you can use that to actually drive your choices in the system as opposed to the traditional quality of service. And so there's a way to actually take quality of service parameters and sum them together with various weights and determine or estimate this log likelihood ratio for quality of experience. Now, you have to use the above training data I talked about, dispatches, to learn these parameters. Once you've learned them, you can update them regularly, but then you can begin to operate without the training data and then adjust your system according to quality of experience. Here's some example. This is for millions of customers in the field, actually, using these techniques. My company uses them. And you can see the call rates here and dispatch rates. The call rates are the blue, and the dispatches are the brown here, for 3 different categories here, where the learning system basically says we have bad quality of experience, then the probability of a call or dispatch is much higher than the probability when it says it's good. Now, that's directly correlating with quality of experience. Here's the system in a block diagram form, where the radio node is now providing these inputs into the Learned Resource Manager. It's computing the probability distributions. It's using those to both set the energies for the different channels, so that could be on, off, use this channel, not use that channel, change the energy. And also it goes through this logistic regression, that's that linear combination I just talked about, of the quality of service parameters to provide guidance or policy on what code and modulation system to use in the wireless system. Now, that can be simplified into a state machine description. Here, that log likelihood ratio basically chooses some coding parameters that are represented by boxes here inside this large state transition diagram. And basically moving to the up and to the right means higher data rate, better quality of service. You'd like to do that, but you'd like to do it so that the quality of experience criteria are met. So you will actually provide guidance to the radio node to move up and to the right by so many positions or not, or to move back down because the quality of experience is poor. So that's the idea behind this reinforced learning, if you will. Here's some other examples from there's several countries listed here. Some of them are shown up on the left-hand screen here, but the amount of improvement, this is stability basically is related to the probability that I just talked about of the quality of experience and the level of improvement. Here's an example on wireless speeds before and after. This is for a Wi-Fi system over a large network. And basically here, brown is very low speed. I don't know if you can read that, but that's below 5 megabits per second. And the red area is between 5 and 10 megabits per second. These are systems that are experiencing Wi-Fi interference. And what you see is those areas getting smaller after this optimization occurring on quality of experience. So it's an AI system that's being used to drive the quality of experience and selecting the right channels, the right coding systems to improve the performance of the network. And those bad users are the ones that are going to create all of the cost for a service provider or all of the angst, if you will, for the user of the service. So in conclusion, it is possible to optimize on the statistical consistencies or the ergodics. They can make a very good improvement through these policy recommendations. You can progress through it in stages and get better and better. And an important point here I didn't say, but you don't have to put everything at the edge of the network in order to get the improvement. You can actually do it based on the statistical consistencies, and often that's better than instantaneously managing at the edge of the network. So we can think of Wi-Fi, 5G, 4G, and others as available for spectrum for sharing using techniques like this to improve the quality of experience. So Wi-Fi, 5G coming together creates a better network with this ergodic spectrum management. So thank you very much for your attention today.
Thank you very much, John. We are running a little bit late. I think you were available during the coffee break, right?
Yes, I'll be.
So if you have any questions or you'd like to discuss any of these topics with John, please take advantage of the coffee break so we don't delay it any further. Still, I would say that 5G will present huge challenges for measuring QoE and QoS and all these kind of things with the variety of services that we'll be experiencing. So the next keynote speaker is Johannes Springer. He comes from Deutsche Telekom, but he also holds a hat under the 5G AA Association, which is the automotive stuff, no harm intended or offense, whatever. That will be definitely one of the key applications that we are expecting for 5G, is our just enjoying ourselves in a car that is self-driven and is not crashing anything. So Johannes, please, the floor is yours.
Great. So thank you very much, Professor Correa, for your nice introduction. I have now to face a big challenge to meet a good balance between quality of service and quality of experience. So I have prepared the presentation for about 45 minutes, so now 15 minutes left. So I tried to make the best to meet the KPIs, quality of service parameters, as a technician. But on the other hand, I'm facing also the need that you are looking forward to a coffee break at 10:30, and that exactly meets hopefully the quality of experience parameters. So try to find a good balance between those two. So I want to give you some insights into the requirements and about the thinkings of the automotive industry when it comes to the usage of the telecommunications networks, and of course all these nice features and functions of the 5G portfolio. And that is exactly the reason why the telecommunications industry and the automotive industry decided 3 years ago to form a new association which is called 5G Automotive Association, which comprises the various parties which are relevant in the automotive space and in the telecommunications space to set up and to deploy communications networks which are really meet the requirements of the car manufacturers and of the first-tier suppliers. So this association mainly consists of 5 stakeholder groups around the globe. These are the car manufacturers on the one hand side. These are the first-tier suppliers, the major suppliers for car manufacturer control units, antennas, all this kind of infrastructure within the vehicle. These are the silicon manufacturers around the Intel, Samsung, Qualcomm, and so on and so forth, which are providing the modules relevant for connected vehicles. These are the suppliers from telecommunications networks, so Ericsson, Nokia, Huawei, ZTE and others are members of that association. And finally, the mobile network operators around the globe. As I said, we are a global association. Why is that so important always to mention? Because the car manufacturers as a stakeholder group has to rely on a global footprint of these features and functions. So it's not important that the function works as a technical matter as such, but it has to be provided on a global basis in the same way in China, in the same way in South Korea, in the same way in the Americas, in the same way in Europe, across the different regions. So what we are talking about, if we are talking about connected cars, autonomous cars, connected mobility in more general, we are facing the situation that the vehicle has to be connected with its whole surroundings, with the whole environment, and that is the traffic infrastructure as such, so the road, the traffic lights, the lamps, variable speed limits, and so on and so forth, construction works. It has to be connected with other participants around the vehicle, so the pedestrians, motorcycles, cyclists, and so on and so forth. And of course, it has to be connected to the network, to the mobile network. And our ambition as 5GAA is to bring all these various communication streams together so that the car manufacturer and the mobility system as such can decide what kind of functionality is used the best for what kind of use case and what kind of purpose. So if we are looking, let's say, one level deeper into that ecosystem, which is changing at the moment drastically around the globe, then we see various capabilities of the 5G networks which are relevant for this communication network. First of all, we see that a direct communication is needed for several purposes. I will come to this later in a while. So the PC5 and the direct communication link gives us all the possibilities to maintain these communication needs. Secondly, and that refers very closely to the previous talk of John about quality of service and quality of experience, if the network, if the mobile network is used, we have to make sure that the quality of service parameters of the mobile network are maintained over the whole period of the use case usage. Or if we are not able as a mobile network operator to maintain the quality of service needs of the network, we have to tell the UE, the car, or the other traffic participants in advance that we might become a problem in a certain period of time. So quality of service plus the guarantees of quality of service plays a very important role. So to bring down the latency requirements, also to increase the availability of cloud and edge cloud services, this is the whole mobile edge computing stuff about, and therefore we are discussing intensively what are the relevant use cases where mobile edge computing brings added value into a use case. As I said, the car manufacturers in the past tend to look onto their vehicles as a, let's say, closed system. And more they realize since the past 5 to 10 years that they have to open that system, to integrate that system, and to mesh the system also with other traffic participants along the road. So the integration of vulnerable road users and the integration of smart devices which are used by these road users, pedestrians, cyclists, is also a very important topic. If communication takes place, especially if physical systems with high mass and more or less high speeds are cooperating on the road and exchanging information, trust and authentication plays a very important role. So you will only rely on a certain piece of information which is communicated to you as a driver or as a vehicle if you can trust this information. And to build trust and to maintain trust over a longer period of time, this is something we have to carefully look into that. And of course, we are using several means out of the telecommunications networks to establish and to maintain trust over the whole journey. And finally, if we want to integrate communication or integrate technology which is relevant for road transport, we are using various technologies around narrowband IoT, CAT-M technologies to integrate this in a cost-efficient and energy-efficient way to make the data which is produced by this infrastructure available for the traffic participants. And very final, one topic which is also very important, which has not that much to do with the communication as such, but with a driving experience and with a safety, safe driving task of the vehicles and also of the other traffic participants is the positioning. So we are also elaborating intensively in working group how can we use the upcoming communication networks to increase the positioning accuracy and also to increase the positioning reliability for the vehicle. So I want to focus on at least 4 of these topics a little bit more in depth and now browse a little bit quicker through these slides. So thanks to the 3GPP standardization process, which already started with release 8 for LTE. With release 12, we got the first release which enables LTE for direct communication, device-to-device communication. Now we are talking about release 14, which incorporates all the relevant capabilities, network capabilities, what I have mentioned earlier, with the LTE vehicle to X, with a clear evolution path to a cellular vehicle to X, a new radio vehicle to X when it comes to the release 16. So we are very closely related and we are contributing in various working groups also to the 3GPP standardization process. The nice thing for the car manufacturers is with these cellular vehicle to X technology that it combines the 2 communication matters which are relevant for the car manufacturers, and that is a short-range communication, a direct communication on the one hand side, and a long-range communication via the network and by using all these kind of relevant functionalities, what I have mentioned earlier, on the other hand. So this one cellular technology stack, which can be integrated into chipsets, modules, communication stacks, that is, from our perspective as a 5GA, the strong benefit of an integrated technology which can be used for the broad variety of use cases and services, and of course different service requirements. When we are discussing about use cases in connected and automated driving, we always investigate that we are not discussing about 10, 20 or 30 use cases. No, we are discussing about thousands of different use cases. The more we are digging into the depths of a use case description, the more we derive that a use case falls into 2, 3 different variants, different options. So the number of use cases and the number of different requirements are so diverse, so that an integrated technology which offers all the different flavors for communication is a very big strength. So as I said, We are now based on release 14, so the 5GA is not that much a research-oriented organization. We are driving standards, as I said, with the 3GPP, but we are discussing also intensively about deployments. So our strong interest is how can we bring these different pieces of technology into the market in, as I said, a global environment. So starting first with the network, with an up and downlink path of the vehicle via the network to various other topics, what we see right now that there are already a lot of good and best practices around the world where commercial services are relying on that network path. So for instance, Mercedes, Daimler, has introduced a vehicle-to-X a bunch of services. One example is shown here where you get information about an upcoming construction work via the network, via a Daimler vehicle backend, which gets this information, for instance, from a road operator and distributes this information to those vehicles which are in the vicinity of the construction work. And this service works. It works in millions of cars. It works not only for construction works, but it works also for a variety of other hazard warnings. Yeah, whether it is hazard lights, whether it is heavy rain, whether it is slippery road, whether it is fog, which was detected maybe by other vehicles which are passing, which have already passed a certain hazard-related location. So this kind of information is gathered by the vehicle, by the sensors of the vehicle, maybe by some information which is produced by the road operators as such, is consolidated in a backend and is distributed to the vehicles. As I said, it works with millions of cars. It works not only for Daimler, it works also for BMW, and it works also for other car manufacturers like Volvo. What we are now discussing intensively is how to bring these different information, which is gathered by various different car manufacturers, how can we consolidate this? How can a Daimler can learn from an Audi? How can an Audi can participate from the information from a BMW? Because it makes no sense, also from a perspective of the car manufacturers, that if an Audi crashes, then the Daimler has to wait in the traffic jam. So this kind of exchange of information via telecommunications networks in a reliable, in a safe manner is one very prominent example we are working right now on. Another example is how to use information out of the traffic infrastructure. For instance, traffic lights, to get information in advance when the traffic light will switch from green to red and vice versa, to deploy services like green light optimal speed advisory in the vehicle, so that the driver gets information, and maybe also from a self-driving car, the car itself controls the speed in a way that a green wave can be maintained over the various traffic lights in the city is another example. And again, this works only if not only one car manufacturer can get access to that information, but all the different vehicles which are on the road get access to that information in a reliable and, let's say, more or less low latency manner. Another example which is shown here is the information about emergency vehicles, which are approaching, so that the driver gets access to that information and can react accordingly, so to open a path for the emergency vehicle which is approaching, so that on the one hand the emergency vehicle can drive hopefully with a very low latency to the destination, and on the other hand that traffic jams and other unsafe situations can be avoided. So all these kind of examples, very often we hear that, of course, these are nice examples, but they work only if the network is there. Of course, if there is no mobile network, then such kind of a use case cannot work, it cannot be maintained. And that is the reason why we are working also intensively to give indications, also based on information which was previously shown by John out of our networks, to give information to the vehicles in advance how our networks will tend to behave at a certain location, at a certain point in time. And to give this information in advance, that will then allow the vehicle to react accordingly, to maybe reduce the speed in advance, maybe to even change the navigation route to the destination to make sure that still a proper network connection is maintained. And of course, if we would introduce that first step of predictability of quality of service, then we can introduce a second step which runs in parallel, that we are not only predicting quality of service, but that we are maintaining and managing our networks in a way that a certain KPI set can be maintained over a certain period of time and over a certain trajectory of the vehicle. So quality of service network slicing is a very important tool for that. And moreover, if the whole thing is latency critical, and some of the examples I have shown earlier, the more we are increasing the KPI in terms of latency, so that some vehicle is driving 200, 300 meters in advance, detecting a certain hazard and wants to transmit this hazard to the following vehicles 200, 300 meters, of course, latency plays an important role. Do we hunt really every millisecond? I would not say that is the case right now, but to increase the stability of the latency, to decrease the jitter of the latency of our networks, plays therefore the edge computing, of course, is a very important component. And finally, one example when it comes to quality of service and quality of experience is teleoperated driving. So all the car manufacturers in our group agree that every automation system will fail at one or the other moment. So the question in that reason is, what will happen if an automation system will fail and teleoperation to make the usage of a teleoperator who steps into the driving task, drives the vehicle into a safe situation, so maybe then the ambulance can come and question what happens, what is the failure of the driver when a vehicle was not able to drive autonomously any longer to a certain location. Again, quality of service is needed for such kind of a service. Yeah? So if a teleoperator relies on the network and it is not clear for a teleoperator that a network connection is maintained properly over the whole period of time, then it will be a great problem. Teleoperation will fail, and then it has to fall back to a safe situation. So, as I said, the second very important component for the automotive industry in the bunch of 5G functionalities is the direct communication. So to exchange information directly between vehicles, between infrastructure, and between other participants on the road is a very important component, which is integrated in the whole framework of the 5G family. So we introduced and discussed intensively this roadmap of the introduction and deployment of the vehicle-to-vehicle and vehicle-to-infrastructure communication. You can see here that now we are in 2019, so a lot of tests were already done. The technology is already available. Here one example of our members from Qualcomm, which is also highly integrated with already existing Release 15 standards, and which will be, of course, then compatible with the upcoming release 16 standards from a downward perspective. So we performed intensively tests to compare the cellular vehicle-to-X technology PC5 with already existing technologies, namely the 11P Wi-Fi related technology, also to get a better feeling about how we can get access to the benefits of a new technology which was invented 2 years ago instead of a technology which was standardized about 10 years ago. So we also did a lot of tests around the world, demonstrated that the technology is feasible. It is integrated also in a variety of funded projects on a European level. You can see that outside at the exhibition hall. We made sure that the technology is interoperable between the different vendors of chipsets. So in Shanghai, we did a big interoperability test between different chipset and module vendors. And 2 months ago, we had a big testing event in Germany at DEKRA. It was also one of our members in conjunction with GCF, Omniair, and ETSI, that the technology works integratively together between different onboard unit manufacturers which are using different chipsets and different configuration parameters. As I said, we have to make sure that the whole technology works not only between vehicles and vehicle infrastructure, but we have to include also other traffic participants on the road, especially when it comes to safety. I'm originally coming from a city in Germany, and that is Berlin. And in 2018, we had in Berlin, the last year, 2018, 41 fatalities on the road. 41 people are killed on the road. And 36 out of these 41 didn't sit in a car. So these are pedestrians, these are cyclists, these are motorcycles, people who are sitting on a motorcycle. So we have to, if it comes to safety, we have to face the situation that we have to take care also for those so-called vulnerable road users who are not sitting in a good shielded vehicle, but which are using also the same location and the same trajectories on the road. So when it comes to the roadmap for the upcoming 5G standards with release 16, it is very important, because we always hear about autonomy and autonomous driving, it is very important to note that driving is not an autonomous activity. Everybody can notice, and you can go here outside of the building and can recognize the traffic. Traffic is not about autonomy. Traffic is about cooperation. The secret of an efficient traffic is that the various participants on the road are cooperating. If we would not cooperate on the road, we would be more reacting like driver beginners, and everybody know how a driver beginner would feel on the road and would behave on the road. So when it comes to autonomous and efficient driving, we have to include the ambition of cooperation. And cooperation is the exchange of information of higher complexity, of intentions, of negotiations between the various traffic participants. What is done by us as human beings, normally very implicitly, by eye contact and other means of our human behavior. And this kind of behavior has to be included into an efficient traffic system, which gets more and more automation skills. And that is the reason why we strongly believe that the exchange of this rich information for enriched perception, for negotiation with regard to path planning, with the negotiation and perception of the environment, a complex environment of a vehicle, and of course, at the end, the coordination between the traffic participants plays a very important role. And that is a very complex task, which can be only maintained if the various information here shown with a very simple example is exchanged on a more or less, let's say, broadband manner between the various participants and negotiated at the end so that the different traffic participants can rely on a certain trajectory planning, which is hopefully then collision-free. So do we do all these kind of efforts alone, even as we are a 120 plus member association? We are meeting 4 times a year around the globe. So the next meeting will take place in Canada, in Toronto, in August this year. We know that the automotive industry and the telecommunications industry, we have to collaborate with other verticals which are relevant for transportation and mobility. And the nice thing when it comes to 5G, and that was also mentioned a couple of times earlier in the introductory notes, the nice thing is that 5G will be a tool which is used for a variety of other purposes in other so-called verticals, whether it is the mobility in a more generally manner, whether it is smart logistics, whether it is the operation of the road and of the traffic infrastructure like garages and so on and so forth, whether it is the mobility as a service and the intermodal mobility planning, whether it is the integration into the homes, because if you are driving home, then the vehicle is also more or less attached to some of the facilities of your home, or whether it is the health, because there are drivers and passengers in the vehicle which might get a health problem. That is also something where all these kind of functionalities have to be integrated from a technology perspective. So the big strengths we see out of the 5G technology portfolio, that this gives us a good and very powerful tool set to integrate all these various needs from that different vertical sectors. We are collaborating intensively with other standardization organizations, also integrating our work items and our concepts, technical papers into projects, which you can see here outside, like Carmen, Croco, Mobix, and others. We are collaborating around the world, China, in Korea, in Japan, thanks to various memorandum of understanding and collaboration contracts, so to make sure that the things we are elaborating in the association are available on a global basis. And that is relevant whether we are talking about quality of service, network slicing, whether we are talking about edge computing, or whether we are talking about other functionalities in that technology portfolio. So, to conclude, we are happy to discuss with the various stakeholders around the globe what's coming next, and not only what's coming next, but what has to be done now to integrate these functionalities into the mobile networks, to bring these facilities to the customers, and to offer the functionalities in a way that the vehicles can make use out of these technology portfolio around the globe for safe, for an efficient, and at the end for a high quality of experience of the drivers and of the passengers in the vehicles and in the different transportation means. So thank you very much for your attention, and I'm happy to discuss one or the other aspects outside at the coffee break. And again, thank you very much for the invitation to that great conference.